into the viewfinder when it rotates in behind the lens. A dab of special cleaning fluid yields a pristine surface. Any dirt on the mirror would create a fuzzy image. The protective cover plates will shield existing openings. Here, the shutter and mirror spin in unison. In this model, the shutter is electronic, so it requires a tiny microchip and electrical wires with plugs on the ends. Technicians scrutinize the parts and connections. Then they test the electronics again to ensure everything is working, starting with the shutter. With all the internal components complete, it's time to install them in the camera's housing. The film gate we saw earlier snaps into position. Next, technicians carefully mount the film guide behind the film, then fasten it tightly. Last but not least, the shutter gently slides into position. They close up one side of the housing with a cover to protect the circuit board inside. Workers then lay an accessory controller gently into the camera's side cover. It takes tweezers and a steady hand to insert this focusing screen through the lens mount at the front of the housing. Finally, the lens takes its place front and center. With the camera structure now complete, workers attach a magazine containing the film. A little nudge here and there leads the film down the right path. The movement swings forward to allow the film to run its course. With the touch of a button, the film successfully races through a mechanical maze. This camera excels at high speed and special effects. All it needs now is some action. It's hard to beat the glitter and glow of glass Christmas ornaments. For many people, the Christmas tree just wouldn't be the same without them. They were invented in the 19th century by a German glassmaker who decided to improvise because he couldn't afford to decorate his tree with the usual nuts and candy. They're Christmas eye candy. Today's glass ornaments are a visual treat. To make some of the ornaments, they start with a sketch and make a plaster model of it. They use it to create a two-part metal mold. They take a glass cylinder and fire its wider end so it softens. The glassmaker blows into the pipe end to stretch the supple glass into the basic shape of a bauble ornament. Other glass tubes are more bulbous at the center, and that's the section that's fired, as the glassmaker blows it into a more elongated bubble. He places that bubble in the mold and blows extra hard. The glass expands into its crevices and takes its shape, a snowman. He burns off one of the blowpipe ends, and then aims the torch at the snowman's nose to pull it out. A quick cool down could shatter this ornament, so he gradually lowers its temperature with a less intense flame. Blowing and molding glass figurines is quick work. The glassmaker has just a few seconds to complete the job before the glass becomes too cool and stiff to shape. The ornaments now head down the line to get some shine. The glassmaker pours silvering solution into the baubles through the stem. She then dips the bauble in warm water. This activates the silvering chemicals, and shaking the ornament accelerates this process. She swirls the silvering liquid around to completely coat the inside of the ornament. A final dip gives this bauble a mirror finish from the inside out. She empties the silvering solution into another tank for recycling. They also use this technique on the figurines, like the snowman. A quick shake gives this guy an inner beauty. Next, they submerge the glass ornament in lacquer to give it some color. The mirror finish inside shines through the lacquer. Now the snowman ornament gets an artist's touch. She airbrushes white lacquer onto the figurine for a frosty finish. It makes the snowman look more like Old Frosty. The artist paints some of the details by hand, like the trim on the hat and robe of the Santa ornament. This gives it a more visual depth. Once the paint dries, she brushes glue onto sections where she wants glitter dust to stick. The glue dries quickly, so the artist applies more. When it comes to Christmas sparkle, you just can't get enough. Next, she makes an incision in the stem and snaps it off. A metal cap fits on the ornament's stub. Time to pack up these fragile beauties very carefully. They put them in boxes that cradle each one individually to ensure they arrive safely. Now these glass ornaments are ready to go out on a limb to add beauty to the holidays. Tires for construction and mining equipment are truly giant-sized. They can be twice the height of a human being and weigh thousands of kilograms. These giant tires also come with a hefty price tag. Just one can cost more than the average family sedan. Giant tires are made to carry heavy loads in conditions that are seriously off-road, like mining and construction sites. To make giant tires, they feed rubber into a powerful mixer. They add sulfur and antioxidants to boost the rubber's durability, as well as recycled pieces of used tires. At the top of the mixer, they add carbon black in measured amounts. It's an oil byproduct that helps bind everything together. The mixing generates heat, which softens the rubber, making it doughy. The rubber dough then falls between rollers that squeeze it into a sheet. The process is called milling. They slice the sheeted rubber and feed it back into the machine several times. This repeated milling essentially kneads the rubber to give it the right consistency. Once the rubber has been sufficiently processed, they feed it to a conveyor. A wheel rolls over the rubber to impress the date and identification number onto it. The rubber then winds through a tank of soapy water. As it exits, it falls over hangers that move it through a dryer. A soapy residue remains, keeping the layers from sticking together as they await more processing. They write the ID number on a sample of the rubber and tag the production run with the same number. This signifies that testing is underway. They tuck the test sample in a canister and send it up a chute to the lab. Once it's confirmed the rubber has the right characteristics, it's ready to be made into the various components of a giant tire. At the next station, dozens of steel cords unwind into a machine. Each cord is made of numerous steel threads, and each thread is brass-plated. These steel cords will be used to fortify the processed rubber. The cords enter a machine called an extruder. It grinds and heats some of the processed rubber and then forces it around the steel cords to encase them. The result is what's known as steel-belted rubber. They cut several of the steel-belted strips on an angle and fuse them together. This exposes steel cord around the edges, so hot rollers seal them with rubber. The steel-belted rubber will make the tires more resistant to punctures. But they make the tire's basic structure from rubber-coated nylon cord. They cut the nylon rubber ply to a specific length. Workers then piece several of those sheets together to form a loop. The pieces adhere because uncured rubber is naturally tacky. A machine rolls the loop to the correct size. They layer more of the nylon rubber ply in a crisscross fashion to add strength. The machine that helps size the loop also applies a thin layer of ordinary rubber between each crisscrossed layer. This thickens the rubber loop. The finished loop is called the band. It's the skeleton of the giant tire. They hoist it onto a cart and move it to the next station. Stay tuned as they shape and inflate this band of rubber to turn it into a giant tire. When it comes to tires, it takes time to supersize. Making a giant tire can take 24 hours or more, mainly because the rubber needs a lot of curing. It's not mass production, it's massive production. As a result, factories only produce a few of the largest ones a day. This machine is about to stretch the big band of rubber like an elastic. The machine pivots, and its many rollers expand and turn to transfer the band to a spinning drum. The machine pumps air around the protruding rollers to make the transfer easier, while the drum turns at a constant speed to aid the process. Once the transfer is complete, the rollers retract and the air escapes. This causes the rubber to shrink to the drum and take its shape. They fold the overlap into the center of the drum. The giant rubber band now has the basic contour of a tire. Another machine coats numerous steel wires with rubber, creating strips of rubberized steel. This will be used to make the bead, the part of the tire that sits on the wheel rim.